All right. Hello, everyone. Happy New Year. Thanks for tuning in to the first Corona developer meeting of 2024. So, real quick announcements and then status updates. So, announcements number one, Happy New Year. Hopefully, everyone will have a good 2024. So, for the developer meetings this year, we're going to do basically one on January 15th and one on January 29th. Basically, this Monday and then 2 weeks from today. Just like what we were doing previously. Let me just double check those dates are correct. Yep. Okay. And the ones after that are currently TBD. I guess we'll also do a switch meeting on January 22nd, and then after that will be TBD. So please go fill out the survey. I put a link to it at the top of the wiki page. There's a little short link that'll take you to the wiki page right there. The survey has 4 different options for the meeting times. So the first one is basically just keep doing the same thing every Monday at 9 a.m. PDT, same as before. What I'm hoping to do is accomplish 2 things. One is to move it away from Monday and Friday, so we're less likely to run into holidays and whatnot. So all the other options are on Wednesday. And then the other thing is I'm hoping to kind of expand the time zone support, if you will, for people that, find the current meeting time to be in the middle of the night or something like that. So the second option is every Wednesday at 9 a.m. The third option is to do something maybe a little bit strange. The first Wednesday of every month. So instead of weekly or instead of every other week, it'll be once a month. But I'll do the meeting twice, once at 9 a.m. and then again at 9 p.m. I'll show the same slides. It's not going to be as great for discussion because, obviously that's better to have everybody in the same place at the same time. But maybe that'll make it easier for people to show up if the, 9 a.m. time slot doesn't work very well. And then the final option is to do every other Wednesday, but alternating between 9 a.m. and 9 p.m. So one meeting would be at 9 a.m., 2 weeks later be 9 p.m., 2 weeks later be 9 a.m. Same kind of thing. You'll get the, maybe better coverage for people to attend the meeting from different parts of the world. So I would appreciate, even if you don't care, even if you can attend all of these, to just pop on the survey and, check the boxes. That would be great. I guess also for people watching the recordings, if you would like to attend the meetings, but the time slot doesn't work, please go mark it on the mark what does work for you on the survey. And hopefully if you can do that by the next meeting, maybe I'll be able to make a decision and announce it during the meeting. Otherwise, as long as it's done by the end of January, we should be able to come up with a good schedule for the coming year. Right. And hopefully more on that once people fill out the survey. I think last time I checked, there were 5 responses. So, and also if you have any other feedback about the meetings, want to see more of something, less of something, whatever, if I'm going into way too much technical detail, there's a box for that too. So if you have any feedback of that nature, that would be great. And you can keep it anonymous. There are boxes for name and email, but you can leave that blank. Yeah, that's all I got in terms of announcements. All right, so moving on to the status updates. Couple of things that I've been working on here, so I'll go over this in a little bit more detail. So I did some optimizations on the Mac and Phi modules, as we're trying to get some stuff to fit on our FPGAs at UCSD. I sometimes have to go through and see if I can squeeze out a little bit more timing performance or a little bit more area on some of these modules. So I made a couple of modifications to the Mac and Phi to try to improve things a little bit. Also, I've been working on the transmit scheduler. So I made some modifications to the transmit status feedback to the scheduler to facilitate implementing the internal flow control. I've also been looking at the queue management logic as well as the scheduler itself and how to support multiple ports and multiple traffic classes on one scheduler. And there's also some updates on the application section pass-through. And I've also been doing some work on the test bed setup here in my garage. So more details on that in the coming slides here. All right, so the Mac and Phi optimizations. Well, a couple different things that I did. One thing that I've realized is that you might as well use flip-flops on the FPGA when you can, because in general, every time you use a LUT, there's going to be a flip-flop right next to it. So if you don't use it, it's not necessarily going to be very easy to use for something else. So adding a few more registers is not necessarily going to be a problem, especially if you can add it in such a way that it doesn't increase the overall latency of something important. So what I've been doing is adding kind of as many registers as I can get away with without affecting the high level behavior of the circuit, because that's going to ease timing closure and make the tools work a little bit better. So I added some register slices to the PRBS error counters in the Phi. If you don't have the error counters enabled, then that doesn't make any difference, but it definitely helps a bit with the timing. And I also added some registers to the CRC logic in the 10 gig, 25 gig Mac. So it does increase the footprint a little bit. It's using more registers, but it doesn't change latency at all. So that's that was kind of the goal. Can I do this without having to, add a whole cycle of latency? So that, I think, is helping a bit with the throughput, or with the timing closure. But I guess it remains to be seen in hardware if that's going to be consistently an improvement. I'll have to see if I can get even more registers in there, because the CRC, I think it's more on the TX side that the CRC logic takes up a lot of logic area. There might be some other ways that can be improved, but adding a few additional registers is a relatively simple thing to do. And also looking at the combined Mac and PCS code, it looks like there's probably a way to, with quite a bit of reworking, to register all of the CRC outputs. But that's a slightly more complicated problem, because a few things have to be kind of reshuffled. Basically, there's a couple of registers, a couple of cycles of delay after the CRC is computed before the signal actually leaves the module. So there's some wiggle room to move things around a little bit and improve that. Right. The other change that I made is to rework some Phi logic to reduce fan-in. Basically, previously I was looking at all 8 bits of the block type, but it turns out that the IEEE guys, when they wrote the spec, they used 8 bits for the block type field, but there's only 15 values, and the 4 MSBs are, unique, basically 1 through F. And you can just look at those bits to figure out what the block type is. So I reworked logic to only look at those 4 bits for, kind of the core of the decoding. And then the other bits are just used to detect errors, right? If you get one of the values that isn't a valid encoding, okay, you flag it as an error. So hopefully that little bit of reorganization will help a little bit with the logic complexity. But that also brings up a random thought. If only 15 out of 256 values are used, is it possible to tolerate a bit flip in there? Seems like it would be with some design. I don't know how you would write code like that besides just a big lookup table, but that could be potentially an interesting thing to think about. Although the flip side, I don't know how much difference it makes, because if you get bit flips somewhere, it's probably going to be causing packet drops anyway, so it might not make that much difference just to consider it as an error. Anyway, these should be in my development repository right now, although I need to do some more extensive testing in the hardware just to make sure I didn't break anything in introducing these things. I don't think so, but you never really know until you do some extensive testing. Moving on to the next thing, updated transmit status feedback. So I know this is something the MLE guys asked about a while ago, but I didn't really have a good feel for the right way to go about doing this. And now that I've been working on the internal flow control, it's starting to become a little bit more clear what feedback is needed and when. And what I ended up doing is separating the transmit status feedback into 3 different events sent over 3 separate interfaces. So basically, when the scheduler requests a packet to be transmitted, the transmit engine is going to, carry out all of the operations associated with that, and it's going to feed back, status of the operation taking place to the transmit scheduler, such that it can track the buffer space that's available, just to make sure it doesn't overrun the buffer and cause headline blocking, as well as reschedule or not reschedule as appropriate. So the first feedback is the DQ status, and this is fed back to the scheduler but very quickly after the transmit operation has been initiated, because this only depends on stuff inside of the FPGA. So the DQ status, it's either going to succeed if the queue was not empty and it was enabled, or if the queue was disabled or didn't have any data in it, then it will indicate that the operation failed. If that succeeded, then the transmit engine will request the descriptor, and once it has a descriptor and has parsed it, it will start the transmit process. At that point, it will issue another piece of status feedback to the to the scheduler, indicating the size of the packet, or if the descriptor read failed for whatever reason. Once the transmit operation completes, then there will be a final update indicating that the packet has been sent and it's no longer sitting in the buffer, so that space can be reused to send another packet. And both the transmit start and transmit complete events contain the packet size, so the transmit scheduler doesn't need to store that internally. And like I said, if an operation fails, the subsequent events are not reported. So, if the queue is empty, you don't see a transmit start or transmit complete event. You just get the DQ status. And similarly, if the transmit start fails because the descriptor read failed, then you don't get a transmit complete event because it didn't actually send a packet. The status of this is that the transmit engine and scheduler have been updated to use these new signals, and it's working in the hardware. And this should also be in the development repo for testing. So far, it seems to be working just fine. Let's see. So moving on to updated queue management. I've also been taking a look at, as I talked about this last time, resurrecting the completion write back code to improve the queue state storage and implement the split pipeline that I talked about before, and to make some improvements to the event generation and to rework some of the internal slot allocation components. So I think this one has been shelved a little bit, so I can work on the transmit scheduler and a couple of other things, but I'll just go over this briefly because I have been getting a little bit closer to getting this to work. So I guess the current queue state storage looks a little bit like this, but I've been thinking about how to make this work for queue pairs and how to make it a little bit more efficient. So the first attempt looked like this, and we've doubled up most of the stuff in the queue pairs, and I also added the LSO offset. But after doing some more ruminating on this, and some thinking about how the queue management logic needs to work and keep track of stuff, I've come up with this second attempt here, which also keeps track of the current slot inside of the queue state, and I give up the LSO offset. I also need to keep a couple of copies of at least one bit. I guess the enable bit I need to keep 2 copies of, one for the send queue and one for the receive queue. So currently I've just been working on implementing stuff on the completion queue side, and hopefully I'll also be able to reuse that logic for the event queue. The queue pairs, that's a little bit more complicated. So I've been thinking about that more from an architectural standpoint. How are we going to make that work? And then testing out some of those ideas on the completion and event queues. So the queue pairs, they don't need the ARM bit and the pending bit, but the CQ and the EQ, they do need that. All right, so one of the things that I've been working on is this split pipeline idea, where the queue state RAM and the base address RAM, that information will be stored separately. And this means that the interference between SQ and RQ operations can be reduced. That was kind of one of the things I was trying to figure out when I started working on, okay, if we're going to do a queue pair, how do we make sure that transmit and receive operations are not interfering with each other? Well, if we have a different pipeline for the send queue and the receive queue, then we can reduce that interference. I don't think we can completely eliminate it, but we can definitely reduce it. So the idea is we have one pipeline for send queue operations that handles all the queue state, one for the receive queue that handles all the queue state, and then a third pipeline for the address. So DMA operations have to hit this shared address RAM because that's the only thing that actually needs the address. And that is shared, but the DMA engine is also shared, so I don't think that really makes much difference. And then register operations via AXI Lite may need to hit multiple pipelines. And I guess one thing I should say is that it's possible that the register operations won't need to hit all of the pipelines if I rework things to do kind of the command decoding first. So if I do that before sending it down the pipeline, then I might be able to go, oh, well, this particular operation only needs to hit the SQ, or only needs to hit the RQ, only needs to hit the address, or need to hit like the SQ and the address, something like that. And then it won't interfere with, whatever pipelines are not being used. So this, I've tested it in hardware in the as part of the new completion handling logic, and it seems to work just fine. Yeah, for completions, you just have one of these for CQs and one of these for addresses. So you don't really get, there's less of an interference problem there, but it is kind of a proof of concept that, the idea does seem to work. So that's that. The next thing that I've been looking at is improvements to event generation. And this is always something that I've been scratching my head over, is how to deal with kind of internal back pressure between different components. So one of the problems with events is that there's a bunch of things that can generate events. And one of these is they can be generated in response to register writes. So if there's back pressure on the event path, well, what happens if somebody performs a register write that could generate an event? Are we going to stall the AXI Lite interface and, cause problems on the register interface side of things? That's not great. So in the initial rewrite of the CQ logic also had a contention problem related to rearming stuff, which caused some problems as well. Stuff would have to get looped back through the internal pipeline, and that was causing contention. So I made a few observations. One of them is that when rearming an empty queue, we don't need to wait for a timeout, or when rearming a queue that has data in it, a non-empty queue, we don't need to wait for timeout. We can generate the event immediately because we don't know how long stuff has been sitting in that queue. If it's empty, then we don't need to do anything. As soon as something gets in queue, then we wait for the timeout and, generate an event. So we don't need to, reallocate any storage to keep track of the timeout. So in order to do this, well, there's two things we can do. If we're generating the event immediately, right, we don't need to allocate anything. But another thing that we can do is potentially add a pending bit to the queue state. And then when a queue is rearmed, we can just immediately set the pending bit without having to, apply any back pressure to AXI Lite or anything like that. It now becomes impossible to lose an event due to this back pressure. We can actually add a T-ready on the back pressure port and or on the event port, and everything will be handled appropriately. And then I can also add kind of a background scrub that goes through and checks to see if those pending bits are set, and if so, it'll generate an event if it can, right? If that port is available, then it can generate the event. And it also eliminates the need to have to store the EQN in the slot state, because if we push this into the queue state, that can be handled separately. And we can potentially use a similar scheme for generating IRQs based on event queues doing stuff. So I've gone ahead and implemented this in the completion handling logic, and it seems to work just fine. So that's good. And the next step then is to improve the slot allocation. And this one I've been working on. I still have a few hazards that need to be resolved that doesn't pass in the test bench, but does at least, it's showing some signs of life. It just needs a bit more work. Previously, the slot allocation was handled outside of the queue state management. And basically, this means the queue state doesn't really care that slots even exist. But rearming queues and a few other things result in this mapping bottleneck to figure out what the slot is for a given completion queue number. And this interferes with trying to handle completions. So if we store the slot in the queue state, well, now we don't need to worry about that because we can just feed it through the pipeline basically, and that's going to be potentially a quicker lookup than what we had before. And yeah, if we have the queue state logic managed slot allocation, like I said, there's a few hazards that need to be resolved, but that potentially is going to reduce the logic complexity as well and remove some other choke points. There were some issues with how this kind of mapping component was implementing the back pressure, that kind of a simplified way that does potentially reduce the throughput, but it works. Flip side, if we're going to remove that, there's a few corner cases that need to be dealt with. So I have this partially working, like I said, in simulation. I need to do a little bit more work to sort out some of the corner cases. But hopefully this will be ready. I don't know exactly when, but soon. And then we can go ahead and switch over to that. And that will give us the ability to, we'll get all the advantages or all the capabilities that was talked about here, as well as, some of the stuff I talked about before in terms of batch completion rate and whatnot, which should hopefully reduce the PCI Express throughput a bit, or not, decrease the utilization a little bit, so we can use more of that for actually sending and receiving packet data, which is always the goal. All right, so moving on to, okay, so the status of this as of right now, I've implemented the internal RAM. I've reworked the internal RAM layout, added the slot bit and pending bit. That's taken care of. The event generation from the queue state module, that's been taken care of. The new split pipeline, that's been implemented. The new slot allocation, that's what I'm working on. Once this is all squared away, then it's on to working on the new descriptor fetch logic and the queue pairs. So at some point, hopefully soon, I'll be able to take a crack at getting that working. All right, so moving on to the updated scheduler and the internal flow control. So with the current scheduler, it basically only works for a single traffic class on a single port. And it doesn't have any kind of internal flow control. It just tries to send stuff, and it only stops sending when the DQ operations are failing, right? When the queues are empty. So that works well enough when the data paths are totally separate, because if the data path backs up, then that back pressure path goes through the transmit engine and whatnot, and eventually reaches the scheduler. But when we have kind of a shared data path, this becomes a problem, because it's going to create headline blocking when you can move data more quickly over PCIe than you can get it out the door onto the wire. So what we need to be able to do is update the scheduler to support multiple ports and multiple priority levels. So we'll need an internal queue per priority per port to track, the round robin schedule. Hopefully we can take advantage of linked lists or something along those lines for efficient storage, because we now have to keep track of all of these different round robin schedules. And as part of that, we can use multiple entries per list element to hide pipeline delays. I did some thinking about, the geometry of how that might work, and it seems pretty reasonable. And the other component of this is implementing internal flow control. So we need to have a quota for in-flight transmit operations per port and per priority. Because without this, we're going to have a nightmare of headline blocking. So the status of this is I've been chipping away at updating the scheduler, and trying to figure out mainly how this internal flow control is going to work. So I think kind of the sequence is I'm going to update it, keep it more or less the same without using linked lists for now, but bring in the internal flow control implementation, as well as supporting multiple ports, multiple priorities. And then once the kinks are worked out of that, then we can work on improving the efficiency of the storage. One step at a time, do this incrementally. So the new scheduler that I've been working on, it has to support multiple levels of scheduling. So we're going to do round robin across the ports. Whatever port, can send data, we'll send data on that port. And then on each port, we'll have a priority arbitration across the TCs on that port. So if you have, say, 4 ports and 4 TCs, and that would be 16 channels. And then that should be a relatively simple logic, couple levels of modules that I already have, the priority encoder and arbitrator modules. And then each of those schedule channels will deal with the round robin schedule for each TC on each port. And one thing that I was trying to figure out here is how to handle all these different ports. And I think it makes sense to permit queues to be scheduled on multiple ports, but on only one TC per port. So if you have 4 ports and 4 priority levels, each queue you could potentially schedule, 4 times, once on each port. They don't have to be at the same priority level on the same traffic class, but there's really no point in scheduling the same queue on multiple traffic classes. And then we need the internal flow control to manage the buffer space. And basically, you can't start an operation or transmit operation unless there's one MTU available buffer. And you can't look at what's actually sitting in the buffer because you have to keep track of stuff that's in the transmit process that will eventually end up in the buffer. And we're gonna have one scheduler channel per TC per port, and we need to track this flow control per channel and potentially support setting different buffer limits and MTU sizes on a per port and potentially per TC basis. So I've been trying to get my head wrapped around how this flow control is going to work. So basically, we need to enforce at least a byte limit, potentially also a packet limit. Basically, we could set it up to enforce both and then kind of disable the packet limit if it's not really needed. But the problem here is that, well, there's a couple of issues. One, we don't know the size of a packet until it's basically being sent, right? It's got to get far enough down the process. We have to read the descriptor until we know how big the packet is. But if we always reserve an MTU size block, then we're not going to be very efficient in terms of how much buffer space is actually being used. So the high level idea is basically to build something that works kind of like a credit card, right? When you want to send a packet, or you have a credit limit of how many credits you can spend, right? How many bytes you can start sending. So when you want to send a packet, the first thing you have to do is you have to place a hold for an MTU size block. Kind of like when you go to the gas pump, you swipe your card, they'll take out a hold for $100 or whatever. And then when you pump the gas, then they'll exchange that hold for the actual charge. So once we know how big the packet is, right? Once the descriptor has been fetched, then we can release the hold and charge the actual amount. And then when the operation completes, you can pay it off. You don't earn any miles though, so this is not a particularly accurate analogy. It's no late fees, no interest, no rewards, but I guess it works well enough at the high level. The question is then, how do you implement this kind of thing in hardware in an efficient way? So the first thing I was thinking about is basically you use kind of scaling, because before you send the packet, or before you know how big the packet is, the only thing we know is kind of how many packets are potentially in flight. Once we've sent the packet, okay, now we know how big it is and we can keep track of that. So the first idea I had was you keep track of the number of packets that are in the process of being sent. And then you basically rescale that and add it to the, kind of a running total of the number of bytes that are in the transmit process that we actually know the size of. The advantage of that with the scaling and shifting, it means that you can adjust the MTU and the buffer limit whenever you want. But the disadvantage is that it's kind of a complex calculation. And part of the problem here is that this kind of sits in a loop. So we have to be able to update the flow control credit count, or you have to be able to update the flow control state whenever we send a packet to figure out if we can send another packet on that same channel. And if we can't do that quickly, then that's going to reduce the packet rate. And that's potentially problematic, right? If we pipeline it to get the clock frequency up, then we can potentially run into some issues. So the question is, how do we do this efficiently without murdering the packet rate? And this particular idea, I don't think is going to be simple enough for things to work. So I was kind of stuck on this for a while until I kind of thought of a different approach for dealing with this. right? Tracking packet counts is easy because you can just increment it and decrement it, right? If you have, if it's non-zero value, you can always send a packet. When it hits 0, then you got to stop. Very simple. Okay, so, well, why don't we have a, so if you have an n byte buffer, n over MTU equals k packets that you can send. So you can start sending k packets right now without having to do anything else. Once the packet sizes are known, then you can sum up MTU minus the actual packet size. For every time that passes an MTU, then you can generate 1 packet credit and send another packet. So the advantage is that the credit check is super simple because we're just looking at, number of packets. But the disadvantage is that, well, somehow we kind of have to reconcile this and get rid of these additional credits that were generated. And I couldn't really think of, the simplest way of managing this. It seems like there's probably some corner cases that could really complicate things. But along these lines, I came up with a third idea. And this is basically to split the credit generation from the actual flow control check. So similar idea as before, where we're using flow control credits where 1 credit equals 1 packet. But the credits are going to be generated and basically accumulated, and then they can be handled by the actual scheduler logic, for sending the packets. So the idea is we have 2 variables, buff size and buff limit. And if the buff size plus MTU is less than the limit, then we can accumulate an MTU size and generate 1 credit. And we can do this as kind of a separate state machine. It can generate these credits and feed them to the scheduler logic, which can then consume the credits. When we start, or when we get a transmit start status report, then we can modify buff size, right? We can subtract MTU minus packet size. When the transmit operation completes, we can subtract off the packet size. And then on failure, we can recycle the flow control credits without changing the buffer size because we've already paid 1 MTU for it. So with this, as packets get freed, well, that will reduce the buffer size value and more flow control credits will be generated. There might be a delay of a cycle or 2 in doing that, but I don't think that's really all that big of a deal, because this is kind of now separate from the kind of scheduler loop that's just looking at now a counter. So the advantage is simple. I think it's going to work well from a timing perspective. We can set the buffer size and MTU size in bytes directly, as opposed to having to do some sort of calculation to figure out how many packets we can send, at the driver level or whatever. And we can change the buffer size whenever we want because this is just checked in this loop. Obviously, to change the MTU size, you have to kind of drain out the credits. So I'll have to figure out the proper sequence for doing that. I don't think it'll be that big of a deal, though. Disadvantages, I haven't thought of any disadvantages yet, so I guess that's a good sign. So I'm going to try to move ahead with this particular scheme, and we'll see how it works. It looks pretty promising from my ruminating so far. Let's see. Now, moving on, that's hopefully going to get rolled into the new scheduler. But there's a couple other things to discuss here. The application section passed through. MLE opened up a pull request for that to add some macro magic to permit passing parameters and ports all the way through from the top level down into the application block, basically. So it looks pretty good, but there's a distinct lack of test benches. So I did comment on the pull request. So if you guys at MLE can add a couple of test benches for that, partially to act as an example, if somebody wants to utilize this and test it, make sure it works correctly, and also partially to get CI coverage so we don't break it, that would be great. And hopefully we can get that merged in soon.
Yeah, I saw that you commented, and yeah, you're obviously right. So there is no test bench for now. We just have this example implementation on the ZC102 included, but yeah, should we look into this?
I think adding a couple should be pretty simple. It's more just
yes.
I want to make sure that it's clear if any additional stuff has to be passed to the simulator so everything works. That there's an example of how to do that.
Yeah. Okay.
Yeah.
Makes sense.
And I think it would be, we might as well add 2 test benches. I think one of them is just specific to the application section logic, because there is I think in the template folder there is a test bench in there. And I think there's an extra test that it does just to access the internal RAM and make sure that it works correctly. So the idea is to just do something similar there to test that in isolation, independent of the board. But it would also make sense, because the whole point of this is that you can access this from FPGA core, is to add another test bench to the ZC102 design that tests the updated FPGA core, which contains, I guess, your GPIO registers. Yeah, that makes sense.
Okay. So there should be one generic and one implementation specific.
Right. Yeah. I mean, I haven't bothered doing that with the other applications, because, the whole point is that it's kind of independent of the board, so you don't really need a board level test for the most part. But for this one, we should definitely have one.
Okay. Yeah.
Yeah, and if you have any questions, we can discuss it on Zulip or on the GitHub issue or whatever. But that's kind of what I'm thinking for now. But yeah, it'll be nice to get this merged in and polished off, and I think there's definitely some people that'll be able to make use of it. I think I know what Tracy was asking about. How do we get a bunch of Zinc specific stuff passed through? I'm like, there might be some ways to do that, but with this, we can add whatever we want. So yeah, although, I think it would make sense potentially to add some additional standard interfaces for Zinc devices and other, hard cores, for getting some sort of access to that from the application section. But that's a slightly different issue. Anyway, that's what I got with regards to that. Hopefully we can get that squared away relatively soon. And the other thing that I've been working on is the little test bed set up in the garage. I think I got everything plugged into the switches. I had to order some more fiber. I got a huge box of LC fibers to get everything all hooked up. And then over the past couple of weeks, a 32 port Paletta switch popped up, so I bought it. Ta-da! 32 ports. Yeah, so this is going to give a lot more flexibility for getting stuff connected. So now I got to go rewire the whole thing with this thing. Yeah, but that's gonna be fun, because I can put both of the the high-tech global FPGA boards on there, and that, well, it uses more than half the ports. Right, 2 times 9 is 18. That's more than half of 32. But yeah, that'll give us, I think, a lot more options in terms of interconnecting stuff. And then yeah, right now I have one node, one kind of host machine that we can connect stuff to. I need to go fetch the other one and get it loaded up with some cards. So yeah, I also have the 100 gig network tester integrated into the setup. Now that I have 2 working CWDM4 ports on there, so that's great. And let's see, there was one other thing. Oh, I also got a PTP capable switch that also has 10 gig uplinks. Another one of these Ruckus ICX 24 port switches. It doesn't support boundary clocks. It only supports transparent clocks, which complicates things a little bit with how things are set up with my setup here, but we'll see. So hopefully that'll enable some PTP related tests. The other nice thing about getting this additional switch is I still have the other 2 switches, and I am looking at picking up a bunch of let's see, SFP28 LR modules for the big honkin' 7132 Arista switch. So we can actually have 25 gig. We can use one of these switches for 25 gig. With the 32 port one, we can set that up for 100 gig CWDM4, everything can talk to everything. Then we can set up another switch for 25 gig stuff. it'd be nice if you could connect one of the LR modules to a QSFP28, but unfortunately the wavelengths don't quite work out for that to be reliable. So yeah, maybe there's some, that might be one thing I can do with some of those which ones was it, the XUP, not the XUP P3R, XUS P3S boards with the VU095 FPGAs. Maybe I can use those as media converters or something to bridge between the two. Not sure. Anyway, so things are coming together there. I need to finish getting a remote access, VPN sort of thing set up, and then potentially I can make this available for people to use occasionally. Yeah, I think this is definitely going to be more useful for things like the testing out the packet switch design due to having the optical switch and both of these high-tech global boards, but potentially it can be useful for doing some other testing with the Corundum itself, and release testing, integration testing, stuff like that to complement the CI stuff on GitHub. All right, so that's about all I got in terms of status updates. People have any questions or comments? Now open things up to discussion. Well, I'll go ahead and get rid of these slides then. Is there anything MLE needs to discuss? We talked about the pass-through.
No, I guess
not
for
at this
now.
Time. Okay.
That's fine. Yeah. Oh, everything's good.
All right. Gwen, do you have a question? Oh, you don't have any questions? Okay. All right. All right. Well, if nobody has anything they want to discuss, then I guess we can adjourn for today. Just if you haven't filled out that survey, make sure you do. If you're listening to the recording, same goes for you guys. If you would like to attend the meetings at some point, make sure you record your what meeting times you can actually attend, so I can take that into consideration when figuring out what we're going to do for the next year. All right. Well, I'll give another opportunity. Any questions or comments anybody wants to bring up? All right.
Sorry. Yeah, a brief question. I'm new to this. So I'm wondering if the schedule is kept the same, like weekly this time, or because I remember last time you mentioned there might be a change in a schedule.
Right. Yeah. So that's what I was just saying about the survey. So we're going to have one more in 2 weeks, and then in February, it's potentially going to be different based on the results of the survey. So there were 4 options that I put together on the survey. I guess I can put that slide up again really quick, just so we're all on the same page here. One moment. Let me pull this up again. But it's great you're joining the meeting. I mean, that's the best way to get involved here. All right. Oops. I need to go to this slide. There we go. Okay. Cool. So, right. There's 4 options that I'm looking at for meetings. The first option is just to keep doing the same thing. The second option is to basically do the same thing, but on Wednesday. The third option is to move it to 1 meeting per month, which might be easier to keep track of than every other week, where you have a potential phase problem. Which week is the meeting and which week isn't? It's the first Wednesday of the month. Well, you can just check that on the calendar. But my thought is to do it at 9 a.m. and then again at 9 p.m. Show the same slides. So hopefully that might work better for people in various parts of the world. And then the last option is basically similar to what we were doing before, but alternating between 9 a.m. and 9 p.m. to hopefully provide more opportunities for people to take part in the meetings from disparate parts of the globe. So,
thanks, Alex, for sharing. I'll fill in that survey. Thank you.
Yeah, sure. Just wondering, what time zone are you in?
Oh, I'm also based in San Diego, so
Oh, all right, cool.
yeah, so like either time works for me, actually. Yeah.
Okay. Yeah, because I know there were a couple people like in Korea or something that have wanted to join a couple of times, but it ends up being at like 2 a.m. or something, 9 a.m. here, so that's not great. I know there was somebody in Australia that was like, well, I would join, but the time doesn't work out very well. So hopefully by providing some options at later times that'll work out better for people. I know I've definitely run into that problem with some of the conferences that have been held. It's like, it's great doing, the hybrid where you can tune into presentations, but if all the presentations are, normal time of day, China time or whatever, then they end up being all in the middle of the night. Yeah, I think that was also, I guess I gave a presentation at FOSDEM, right? Myself and Ulrich, and we had to find a time that wasn't that wasn't just crazy from my time zone to tune in. I think I still had to stay up till like 1 a.m. or something. But
yeah, we got a very early time slot, so it was very late for you. Yeah, right.
Well, it beats the alternative. I mean, some of the other times probably would have been really bad. So that worked out reasonably well. So I'm okay staying up, till 1 a.m., but that's not the case for everybody. And 2, 3, 4 a.m., yeah, that's probably out of the question for most people, unless you're, working the night shift or something. But usually you don't do that in this type of engineering, right? Anyway, I'll go ahead and get rid of that. So, how do you say your name, Matt? Lian Chung? Are you at UCSD? Or are you just...
Oh, yeah. So I'm currently a fifth year PhD student working on these like programmable hardware. I used to work a lot on these like Intel programmable switches, and also like these. I also work these days on these like FPGA NICs. So that's why I found a great resource here. So I'm also staying in San Diego because my family is living here. But technically, I'm a PhD student at UPenn, which is in Philadelphia.
Okay, gotcha. Well,
yeah,
that's pretty cool. Well, I mean, let me know what kind of questions you have. Maybe we can meet up sometime if you want.
Yeah, of course. Is it like what is the best email or forum or whatever phone to reach you? I definitely want to learn what is going on.
Well, you can certainly reach out on Zulip, and then if you've cloned the Git repository, my email is in all the commits. So
yeah,
whatever works. Yeah. Are you interested in kind of building stuff on top of Corundum or potentially working on Corundum itself?
So I'm interested in both, honestly. I've tried a few yeah, so I'm thinking about both actually. Yeah.
Okay. Well, it'll be interesting to hear what kind of ideas you got bouncing around. I'm guessing you have some hardware to work with.
Yeah, I set up yeah, I got a donation from Xilinx University program. They kindly offer these like two U280 NICs.
Oh,
I
the
also
E280s.
bought
Yeah, those are good.
yeah, and also bought one 200 because originally I thought they might not offer it, but unfortunately there's two and I set them up in our lab and there are three in total currently to work with.
All right. That sounds like a pretty nice setup. Yeah, I guess
Yeah.
one thing that you can run into as well is making sure you have enough oomph out of the host machines that those cards are installed in, because 100 gig, that can be quite a bit of bandwidth.
Yes.
That's one thing I've noticed with a lot of kind of consumer motherboards. You can be hard pressed to get more than one card in there that can use 16 lanes. So
Yeah. So the one I think yeah, for that definitely, like originally the machines in our lab are too old for it. They can only support one 16 lane PCIe 3 maybe. And also like so that's why yeah, we fortunately we got these like R7525 machines, which are from Dell. I think they sort of support more than, I think they support four full high cards, and which is good.
Yeah, it can be annoyingly hard to find servers that can fit full height double wide cards.
Oh,
it's
yeah.
becoming more common. It used to be like, who the hell would use one of those things in a server? Because, you know, people are just putting in RAID controllers and things like that are all single slot. But with the advent of machine learning and whatnot, now people are like, okay, how many GPUs can I cram into a server? And if you can get your hands on one of those GPU servers, they usually work pretty well for FPGAs. But unfortunately, there's not too many of those on the used market yet. So that definitely makes it a little bit more difficult to build up a test bed.
Yeah.
But the flip side, you can get a lot of pretty nice hardware on the used market. So I know we just bought 20 servers at UCSD for like $400 a pop or something. I can't remember what the actual price was, plus CPUs. Obviously they don't fit the double height cards, but we had a bunch of single slot cards that went into those things. So yeah, a few years old, but they can throw 100 gig without too much difficulty. So obviously, you know, getting the latest and greatest is good, but if you can stretch your research budget
Yeah.
by getting used hardware, that can work pretty well too. All right, well, we should stay in touch.
Yeah, thanks. It's great to finally find out this resource. Yeah.
Yeah, sure. Looking forward to it. All right, anyone else have any questions or comments? I don't want to put anybody on the spot. I guess not. All right, going once, going twice. Well, Happy New Year, everyone. Make sure you fill out the survey if you haven't already, and I'll see you guys in 2 weeks. And I guess I should mention we are planning on doing the Switch Dev meeting next week, as usual. I'll have to figure out what's going to make the most sense, you know, for the rest of 2024, based on the results of the survey, how we're doing the Switch meetings. But yeah. Anyway, see you guys next week or week after next, depending on whether or not you're interested in the Switch. And Happy New Year. Take care.
Okay, thank you very much, Alex.
Thank you.
Thank you.
Bye.
Bye, everybody.
See ya.